Third one, calculate sum and product of first n numbers. We have to calculate sum of first n numbers and product of first n numbers. I'll show you the code because there is a bug here in the code. And one more concept this code is covering is, here we have to return two values. So people who code in C++ will return vector. We could have returned array also. People who code in Java will return array list or list. People who code in Python will return list. People who code in C# will return list. So that will be our return type. So this code is calculating sum of first n numbers and product of first n numbers. So 3 questions to you. Bug, complexity.
T is 0. It shouldn't be 0. Every time it returns 0. T.
Yes. So sum we should initialize with 0. So since we are adding, we are saying initially we have 0 and we keep adding to 0. Product we should have 1 because if you multiply anything with 1. So that was the mistake. Any other mistake? Calculation of sum is happening fine now. Product is happening fine now. Then it's the syntax of vector. We are adding sum and product to it and we are just returning the vector. So bug is fixed. So this was the bug. Now what is the time complexity of this solution?
N.
Saying n square, think of it, these loops are nested or they are sequential? They are sequential.
Sequential.
One after another. So this loop is one sequence, this loop is another.
Big O of
The
N.
complexity is big of
N.
n. Practically, can I say it is 2n?
Yes.
Yes.
That's N.
So practically it is 2n, big O wise it's n. What is the space complexity?
For
Of n. Why? We are using a vector. What is the size of the vector?
N.
Here we are putting only two values. If n is 100, then also we will put two values. If n is 1000, then also we will put two values. Is this vector really dependent on the n? No. That's why it is, again we will say it is big of 1 only because it's constant. Makes sense? So the learning is, if we are using a vector or array, it doesn't mean that complexity will always be n. We should also see in worst case how many spaces we are using in that the data structure. Right? Now I can remove this second loop. I can put everything in one loop. So it will be, can I say I can do both calculations in one loop? Does it reduce the time complexity? Practically also it doesn't remove because this calculation, they are still two separate instructions. But code wise we have optimized.
Okay.
So whatever we were doing in two separate loops, now we are able to do that in single loop. This solution we can say is little optimization, but it's not, I'll say, it's not a new solution or new innovation. Right? Why? This is one instruction, this is one instruction. So still two instructions are running. Previously also, if you practically calculate, you were running n instructions here, n here. Now if you move two instructions inside one loop, still it is two instructions running n times. Still 2n. But in real world people say, if there are two instructions, also treat them as one if they both are constant time. So that may give us an illusion we have optimized, but it's just the code optimization, not the complexity optimization.
Right? First point is going from 0 to n.
Yes.
Again it is going from 0 to n. It is going 2 times to traverse the array.
Correct.
Then it is being only 1 time that traverse.
Here array you are traversing once, but inside the loop you are still running two operations. So even if you are going n times, you are running two operations every time. So it is 2n, isn't it? So first time you run two operations, second time you run two operations, nth time you run two operations. So operations wise, if we count, they are 2n. But if you treat both of them combined, let's treat as one operation, then it appears that we have optimized. This expression is taken as one instruction. This is one instruction, this is one instruction. But in real world, we actually combine, we say Even if there are two statements which take constant time, we say, okay, this is one statement only. Treat it as a black box. If it is one instruction or multiple, treat it as one. If you see that way, you may say, I have optimized. But it's just the number of lines of the code we have reduced. We have cut down one loop and we are doing one pass over the array. Many programming problems will require solve this problem doing one pass of the array. Okay.